This help video is based on the Syvecs knock control strategy. The point of this video is to explain briefly how our knock control system works and how to go around about setting it up and calibrating it to work for you and your engine. The first things we need to go over are the I/O configuration area to assign how the knock control system is set up. If we go down to I/O configuration and pin assignments and right to the bottom, you will find the different inputs for different cylinders and the knock input. Now on this particular engine it is a V6 engine, so on the different banks we've assigned each knock sensor to each bank. So bank 1, which has cylinders 1, 3 and 5, is assigned with one of the knock sensors, and the other bank, which is 2, 4 and 6, is assigned with the other. This is important, this is set up correctly, obviously because it plays a big part in how the detection strategy works. Once these are set, it is a blue item, so it needs to be programmed by going Device, Program, to ensure that the actual data is locked into the ECU and saved. This takes a mere 2 seconds, a reboot is done and the ECU will come back online in the top right hand corner. Now, an important thing which many people miss about the knock control strategy is you first can turn it on and off under the calibration switches. It is important to go under knock control and select the knock control enable to make sure that it is set on and turned on for the calibration switches you're going to be using. If you want to be able to turn it off for one particular map, you can do so, but please make sure that that is first of all enabled. There is an option to advance the ignition when the knock control is active to bring it to the point of theoretical MBT. This can be done on the ECU, and we'll explain that a bit more further later in the video, as well as the cylinder trim learning mode. First of all, let's go over the detection setup. So down at sensors and knock control, you'll find a bunch of options. If you have an S6 which has got the basic knock control, some of the parameters here won't be available to be seen, but this is actually on an S8, so I will go over all of the aspects, and if you don't have them, then you can actually upgrade your S6 to full knock or just work with what you have. The first thing to set is the window start and window end. This is based on the actual window and where the Syvecs strategy will be listening for knock after the ignition event has occurred, or slightly before if you wish. Set this as you choose. The next thing to go over is the bandpass filter frequency. Depending on the engine which you have, the filter or the frequency which knock occurs at is dependent on the bore size of the engine and many other variables. There's some real good reading on this on the internet under Google, but if you do know the bypass frequency which you need for your engine, then punch that in here. If you currently don't and you want help with that, then get in contact with the Syvecs technical support team who can help you with fulfilling this frequency to suit your engine. Now, the gain control is an overall gain. What we suggest doing this is actually opening up the actual live knock traces from each cylinder. Now you can do this two ways. Either open up the gain window here and double clicking on the actual cylinder 1 knock, cylinder 2 knock, cylinder 3 knock, cylinder 4, cylinder 5, cylinder 6, however many cylinders you have. Once you're viewing these live, when the engine is running, we want to basically trim the gain to make it so that when the car is idling, it roughly has values we recommend in the area of around 3. If it is not viewing any values on the bottom gauges, then it can be that the RPM for the knock detection is not currently high enough. So you can change this under here. Obviously values above this is when the knock detection becomes available. So please make sure this is lower than the current RPM you are actually idling at, etc. Once you set this up, change the gain. Obviously this is green, so it can be changed live. Change this until your knock values are recommended around about the values of 3 at idle. Once you've got that set, the integrator time consent is something that we don't really get involved with explaining because we don't want to educate our competition. If you'd like to know more about that or need help with that, if you find the knock control is not working well enough for you, then please get in contact with you and we can talk you through ways that you can change this. But generally speaking, over the last 5 years I've found that the integrated time consent is roughly around about the 200 microseconds. The gain tuning then allows you to be able to define get the values at the bottom on the cylinder 1, 2, 3 and 4 and 5 and 6. So they're roughly around about the same values. Now this is difficult to be able to do at idle because of the normally there's not much noise going on in the actual cylinders. What we suggest with this is, again, to do a run and do a log of a pull of where you know there is theoretically quite a far away from MBT and a no knock will be present. Once you've done a run and you've logged cylinder 1, knock 2, 3 and 4 at a speed that is over 200 Hertz, we recommend pulling the log back off, which is explained in our basic manual how you set that up, and making sure and tuning the gain tuning to roughly all of the values are roughly around about the same. Once you've done this, it makes life easier to actually get the event detection set up and working well for you. As you can see on this particular setup here, the knock sensor is placed on the engine, on the V6 engine present here, in the middle cylinders, which are actually where 3 and 4 are. So you can see that the values here for the gain are turned down a lot. Again, this is green, so it can be changed live. We've already talked about the knock detection enable engine speed, and that's that set. The base level clip is the value of what the knock base values which come off the ECU, which we're going to talk about in a moment, will be clipped at, i.e. they won't go higher than this value. Generally, if they're going higher than 75, either the gain is tuned wrong on the gain control, or there is a severe knock event which need to be dealt with. The base level breakpoints, generally on most engines we would recommend leaving this well alone. Okay, so we come to the event detection level. The way the knock control strategy works is you have a knock base value, which is shown here. The knock base is a value which is a rolling average that is taken every cycle of the engine. So for example, if you were looking at your knock traces and you had a value here of an average of, say, around 11 on cylinder 5, if there was an instantaneous noise or a change on the knock base value, or the knock level that comes in off the sensor of, say, 18 above the knock base of, say, 11, so where it was at 11, say if this value on the knock as shown in this log here suddenly jumped up to 30, all of a sudden the knock control will detect that as an event. As soon as it sees an event, the knock control will become active, which is in a different section. But the important thing to explain here is about the event detection. Okay, so based on the knock base, okay, your average rolling value that's in your log, say for example again here, the average is around here of around about 9 to 10. If you had an instantaneous event of a knock on the actual knock trace, it would be relevant to this table, and if it goes above the value which is present for the knock base value, then an event will be logged and it will be dealt with under the knock control, which is higher up in the table tree of the calibration. Now the severe event detection level is what it says in the name. In the event of, say, your knock base being 10 and all of a sudden there was an instantaneous event of knock that went above 33, the severe event detection flag will be logged, and in which case the knock control will deal with a severe event. So what we've done, we've talked about that. The failure detection basically allows you, so if the sensor gets saturated, i.e. it starts seeing values of well above 75, we class the sensor to be saturated, and an error will be brought up in device errors. The no signal detection enable engine speed, throttle position and engine manifold pressure allows you to basically punch in values in there, so if there was no signal coming on any of the knock 1 to 6 or up to 12 if you have a 12 cylinder, it will flag up an error in the device error again. So we've talked about how the knock detection is set up and how it works. What we want to do now is go to the knock control. So the knock control, enable throttle position. When the throttle is above 5%, the knock control becomes active. When the manifold pressure is above 1000 millibar, on this base map we've set the knock control to become active. Now what you can do is you can obviously set an ignition advance when knock control is active, which we talked about earlier under the calibration switch area. Here you can set a limit to the actual amount of ignition advance which can be put into the engine when the knock control is active, to actually help it try and push the engine to its theoretical MBT. In most instances, we don't recommend using this unless it's a serious engine which needs to be at the limit of its maximum base torque constantly, like used in the Le Mans 24 series, which uses the same ECU. But for general road cars and for club and motorsports, such thing, we just tend to recommend using it on the retard manner and fuel cut manner in order to protect the engine. We've got a disable time after gear cut. So after a gear cut happens, obviously a lot of noise can happen in the cylinder where you have, say, a gear cut of, say, full fuel cut severity or ignition cut. So we leave it 100 milliseconds before the knock control will become active again, because you might find that, say, noise has been seen and event detection becomes active. The reset ignition retard on gear cut is there to allow you to actually reset the ignition retard back to 0 if you want to. Now, when the actual level of the knock goes over the knock base, as we talked about in the event detection table, if it goes over that value, you have the first event ignition retard step. So if, for example, it went over that value, the first thing that would happen is the first event ignition retard step would be taken into account. So you can set this up to 5 degrees, i.e. when it first sees the ping, it will pull 2 degrees. You can see that working here in this log. For example, this particular engine, you can see here the ping of knock on cylinder 1 and 4. Straight away, it pulls the timing out of 2.5 degrees, which is the actual, on this particular car, was set as the first event ignition retard step. This works particularly well, as calibrated correctly, and actually gets rid of the knock event straight away. It is important to make sure that the knock event, first event ignition retard step, is sometimes quite severe, because in the event it's not dealt with quickly, you can get something called runaway knock, and it's important to make sure that you get hold of the cylinder pressure quickly to prevent no damage is done on the engine. After the first event ignition retard step is kicked in, you then got the ignition retard step. So again, if after the first event the ignition retard has been 2 degrees has been pulled out, and then there is another ignition knock event, another degree will be pulled out. You can set this to as much as you like. The severe event ignition retard step is based on the same principle. So in the event that a severe event occurs, i.e. it goes above the severe event detection level, then the severe event ignition retard step will be 3 degrees, because it's much more, it's obviously been a severe instance of knock, and you want it dealt with extremely fast and extremely quickly. So you obviously pull out more timing, etc. Now, in the event, you can actually set the maximum amount of ignition retard. So on this particular car, it's set at 10 degrees. Now, it's set at 10 degrees for a reason, because at 8 degrees, we have full fuel cut shutdown, i.e. if the engine is knocking that much that it's pulling out more than 8 degrees or 8 degrees of timing, there is obviously something severely wrong with that cylinder, i.e. an injector failure or something else that is going on with the cylinder, that you want to basically be able to shut that cylinder down to protect the engine. So you can set here the threshold for the full fuel cut, which will actually shut the cylinder down completely, make the driver aware that there is a problem, and obviously try and get the problem resolved as quickly as possible. Now, when there is actually no event on the knock detection, the non-knocking cycles per reinstate step will be applied. So every 3 cycles of the engine, 0.5 degrees of timing is added back in. These you can actually change here though, to make it, obviously if you want it to be slower, then you increase the amount of cycles. If you want it to be faster, then you lower this, and if you want it to be more aggressive how fast it puts back in, then you increase the ignition reinstate step. The ignition retard when knock sensing fails, so if it sees that there's no signals on the knock sensor at all, you can actually make it so it defaults and pulls out an X amount of timing. On this particular car, it was set at 5 degrees. Events for maximum retard for ignition shutdown, so in 5 cycles, if there is a maximum retard hit, then it will shut the cylinder down completely. The pre-ignition event for cylinder shutdown works in the same manner, but we'll come back over that a bit later. So, once you've set that up, and you've got your knock control working, you should hopefully find that it works particularly well to make sure that in the event of a knock event, as shown here clearly in this log, that it's pulled out quickly. It is important to make sure that the knock is logged extremely fast. On this particular one it was set at 100 Hz because it was a smaller size engine, but obviously it's important to remember that if you are revving it higher, that you want to be logging it faster, obviously because the events happen quicker. Hopefully this has been useful, and hopefully it gets you to get the knock control working well for your engine. If you need any more help on the knock control strategy, please get in contact with the Syvecs Europe or Syvecs US help team. Thank you very much.